The random motion of holes and free electrons due to thermal agitation is called diffusion. A hole and electron in close proximity would tend to attract each other. The battery connections required to forward bias a p-n junction are positive terminal to P and negative terminal to N. In the depletion region of a p-n junction, there is a shortage of holes and electrons. A p-n junction acts as a unidirectional switch. In an intrinsic semiconductor, the number of free electrons equals the number of holes. When the temperature of an extrinsic semiconductor is increased, the pronounced effect is on minority carriers. The leakage current in a p-n junction is of the order of microampere. The leakage current across a p-n junction is due to minority carriers. With forward bias to a p-n junction, the width of depletion layer decreases. At room temperature, an intrinsic semiconductor has a few free electrons and holes. At room temperature, an intrinsic silicon crystal acts as approximately as an insulator. A forward bias p-n junction diode has a resistance of the order of 0. In a semiconductor, current conduction is due to holes and free electrons. The impurity level in an intrinsic semiconductor is about pure semiconductor, 1 atoms per XOR atoms. The resistivity of a pure germanium under standard condition is about 60 cross cm. The most commonly used semiconductor is silicon. A pentavalent impurity has 5 valence electrons. Addition of trivalent impurity to semiconductor creates many holes. As the doping to a pure semiconductor increases, the bulk resistance of the semiconductor decreases. A hole in a semiconductor is defined as the incomplete part of an electron pair bond. A trivalent impurity has 3 valence electrons. The strength of a semiconductor crystals comes from electron pair bonds. A semiconductor is formed by covalent bonds. The resistivity of pure silicon is about 6,000 cm. When a pentavalent impurity is added to pure semiconductor, it becomes n-type semiconductor. An n-type semiconductor is electrically neutral. Addition of pentavalent impurity to a semiconductor creates many free electrons. When a pure semiconductor is heated, its resistance goes down. A semiconductor has generally 4 valence electrons. A semiconductor has temperature coefficient of resistance. Negative has negative temperature coefficient of resistance.